Welcome to Kapati Maths classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 10th video on single variable calculus of chapter functions. In this video, I am going to discuss some numerical problems based on transcendental functions, especially on exponential and logarithmic function. Find the domain of f of x is equal to 1 over root of log of x square minus 7x plus 13 by base half. Okay, now the domain depends on the working rule of the function. Here, solution. Number 1, this function is in the form of 1 by root f. So domain of 1 by root f is equal to x such that my f of x is more than 0. This is number 1. Therefore we have log of x square minus 7x plus 13 base 1 by 2 is more than 0. Number 1. And number 2, because of the log function, log accepts only positive real numbers. Therefore, x square minus 7x plus 13 and x square minus 7x plus 13 is more than 0. Number 2. Now, whatever real number subset you get in the case 1 as well as case 2, you have to take intersection of those sets. So take 1. Take 1. Log of x square minus 7x plus 13 half is greater than 0. Now here log of something base is more than 0. Now you have to remove the log. Now how do you remove log? This implies x square minus 7x plus 13 less than half to the power of 0. Why my greater than symbol convert into less than? Because the base is less than 1. Whenever the base is less than 1, inequality will change. Okay, now this is not one equation. This implies x square minus 7x, this is 1, brings at plus 12 is less than 0. Therefore, my x belongs to 3 to 4. Okay, we got answer 3, 4 using the first condition. Now take second. Second one, x square minus 7x plus 13 greater than 0. Now if you observe carefully, the quadratic expression x square minus 7x plus 13, it's a discriminant. Let us find discriminant. It's a discriminant is equal to 49 b square minus 4ac 4 into 13, which is less than 0. When for a quadratic expression, if the discriminant is less than 0, sign of the expression is same as sign of the x square quotient. So in this case, here we have, therefore, x square minus 7x plus 13 is more than 0 for all x belongs to R. Therefore, here x belongs to R. So, in the first one I got 3 to 4, second one I got x belongs to R. Therefore, domain is equal to 3, 4 intersection real number set is nothing but 3, 4. So here in this question, important things is how the greater than symbol is converted into less than because of the base. And here x square minus 7x plus 13 is more than 0 for all real numbers because its discriminant is less than 0. Find the domain of f of x is equal to log 1 plus x cube base 10. Okay, f of x is equal to log 1 plus x cube base 10. Here also base 10. we have two logarithms. First one, I consider this part log of something, and this expression must be more than 0. So first one, accepts that log of 1 plus x cubed is more than base 10 is more than 0. This is number 1. Number 2, we have one more log. Log of 1 plus x cubed. So here, and 1 plus x cubed is greater than 0. Number 2. Now you have solved these two inequalities and you have take their intersection. So take one. Take one. Log of 1 plus x cubed base 10 is more than 0. This implies 1 plus x cubed is greater than 10 power 0. 1. 10 power 0, let one more step. And here the inequality greater than became greater than because the base 10 is more than 1. Okay. So here this implies 1 plus x cubed is more than 1, or my x cubed is more than 0. This implies my x is more than 0. So here we got x belongs to 0 to infinity. Number 1. Number 2. Come to second one. 1 plus x cubed, oh, is greater than 0. 1 plus x cubed is greater than 0. This implies, number, take 1 plus x cubed greater than 0 is nothing but 1 plus x into 1 minus x plus x square is more than 0. Now here, product of two expressions is more than 0. Either both of them must be positive or both of them must be negative. Now if you observe carefully, this 1 minus x plus x square, 1 minus x plus x square is greater than 0 for all x belongs to R. Why? Because it is a quadratic expression, its discriminant is less than 0 and x square quotient is positive. Therefore, definitely my 1 plus x must be more than 0 or x must be more than 1. So here I got x belongs to minus 1 to infinity. This is number 2. Now you have to find intersection of these two. So 1 intersection 2, nothing but 0 to infinity intersection minus 1 to infinity is of course 0 to infinity. Why? Because 0 to infinity is subset of this set. Therefore, here the domain in this question is 0 to infinity. Next question, find the domain of log of 2 times log x base 10 plus 1 over minus x base 100x. Just it is a normal logarithmic function. Okay, now solution. Solution. First one, because of the log, okay, first I write this step. F of x is equal to, you have log of 2 log x base 10 plus 1 by minus x base 100x. First I consider this log. Because of log, this expression must be more than 0, that is 0.1. First of all, we have 2 times of log x base 10 plus 1 over minus x is more than 0. This is number 1. Number 2, here also you can find a variable, that is 100x. The base must be more than 0 and not equal to 1. And 100x is more than 0 and 100x is not equal to 1. Two cases. Or I can say my x is not equal to 10 to the power of minus 2. Here 100x is greater than 0 and x is not equal to 10 to the power of minus 2. So here we have x is greater than 0 means all the real numbers more than 0 except 10 to the power of minus 2. So here we got x belongs to 0 to infinity minus 10 to the power of minus 2. Or I can write 0 to 10 to the power of minus 2 union 10 to the power of minus 2 to infinity. This I got as number 1. So in this case I got x belongs to 0 to 10 to the power of minus 2 union 10 to the power of minus 2 to infinity. Now take 2. So take 1. 2 log x base 10 plus 1 by x is more than 0 minus x. Now in the first case we got 100x is greater than 0 means x is positive. When x is positive, my negative x is negative. When you do cross multiplication, we get 2 log x base 10 plus 1 is less than 0. Okay, by using cancellation law, or I can go for 2 log x base 10 is less than minus 1, or log x base 10 is less than minus 1 by 2, or my x is less than 10 to the power of minus 1 by 2. Now the less than symbol became less than because this 10 is more than 1. No change in the inequality. So x is less than 10 to the power of minus 10 is nothing but 10 to the power of minus 1 by 2 is 1 by root 2 to 10 is 0.3 something, you get it. So here we have all the values minus infinity to 10 to the power of minus 2 minus 1 by 2. Therefore in this case we got x belongs to minus infinity to, I write 1 by root 10 is equal. This is number 2. Now you have to take intersection of these two. Again, I will take the real line element. The first one is 0 to 10 to the power of minus 2 and 10 to the power of minus 4 to infinity. I take like this. Next one, 1 by, this is 10 power minus 2 is 0.1. So definitely somewhere here 0.3. And second one is this part, and this is equal to 10 to the power of minus 2. Sorry, 1 by 10. Now common part is nothing but this and this. Therefore the final answer is, 0 to 10 to the power of minus 2 union 10 to the power of minus 2 to 1 by root 10 or 10 to the power of minus 1 by 2. This is the answer. Please take it. Now find the domain of log of root of x minus 4 plus root of 6 minus x base 10. Okay, because the logarithm function, my x such that under root of x minus 4 plus root of 6 minus x must be more than 0. Okay, therefore we have under root of x minus 4 plus root of 6 minus x is more than 0. Of course, there are some of the two terms. Again, root is there. You have to consider this part, x minus 4 must be positive. So we have x minus 4 is greater than 0. Therefore, x belongs to 4 to infinity. And second one, and 6 minus x is greater than 0. This implies my x is less than 6 or x belongs to negative infinity to 6. Now, intersection of these two is equal to, therefore, domain is equal to 4 to infinity intersection minus infinity to 6. So, answer is nothing but 4 to 6. Domain of this function is 4 to 6. Find the domain of f of x is equal to square root of log of 3x minus x square by x minus 1. Here, three functions are involved. Number one is a square root function, number two is logarithmic function, number three is a rational function. You have to consider all these three conditions. Okay, so solution. First, I will focus on square root. Square root of something, it must be more than 0. So first of all, x such that log of 3x minus x square by x minus 1 base 0.3 is more than or equal to 0. This is number 1. Number 2, log function, whatever expression is there, 3x minus x square by x minus 1, it must be positive. First point 1. Second one, 3x minus x square by x minus 1 is must be positive. Number 2. Any conditions are there? No. Oh. Now take 1. Take 1. Log of 3x minus x square by x minus 1, 0.3 base is more than or equal to 0. Now you have to remove the log by using logarithmic concept. Before removing the log, means you are converting into exponential. Here the base is 0.3. 0.3 is less than 1. Then when you remove the log, it will become 3x minus x square by x minus 1 less than or equal to 0.3 all to the power of 0. This is very, very important. So, or I can have 3x minus x square by x minus 1 is less than or equal to 0. We have to solve this equation. The space is not permitting me to clear this one. So, I solve here 3x minus x square by x minus 1 greater than 0. That means here we get negative infinity to 0 and 1 to 3. And the first one we got this one. Now, I mapped here 1 minus root 2 to 1 interval, 1 plus root 2 to infinity, the second interval. And from that one, I got negative infinity to 0 and 1 to 3. So, you need to focus on intersection of these two. This part and this part. Therefore, the final answer is, in this question, 1 minus root 2 to 0 union 1 plus root 2 to 3 is the final answer.